the position and the displacement vector. First of all, we talk about the position. We consider a point A. When I say a point, it means a position. We don't have any object, just a position. A point A, to find the position vector of this position, it's noticed by RA. Geometrically, it's a vector between the origin to the point. Here I have O, Y, and X. RA is the position vector. Here we have the components vector of the position vector, XA and YA. So XA and YA are the component vectors of RA. So RA equal XA plus YA. If I have another point B in the space, the position vector of B is RB. We can here we have x-axis. Okay, so we have RB, XB, and YB. Here you have XB, the X component vector, and we have YB, the Y component vector. So RB equal XB plus YB. So here we have to remember the position vector geometrically is represented by a vector from the origin to the point. To RA and RB must be represented by the components vector. Now, if we have an object at the point A, here we have an object, moves in this way to the point B. So this is the initial position and this is the final position. I ask you to find the displacement. The displacement between A and B. The displacement, it means I want delta R AB. As definition, delta R equal the final position vector minus the initial position vector. It's important, this equation. Geometrically, a displacement, it's a vector between the initial position is directed to the final position. We can choose, for example, green. So this is the displacement delta R AB. Okay, we substitute the position vectors of A and B, XB plus YB minus XA plus YA. Here we have XA in the positive direction, YA in the positive direction, I and J. The same for B, XB and YB. So we can write XB. Here, be careful. If XB is directed in the negative direction, we have to put minus I. Okay? But in our case, XB is directed in the positive direction plus I and XA also. So we put XBI. The same for YB. YBJ minus XAI plus YAJ. We take a common factor I, so XB minus XA plus, we have XB here minus XA plus YB minus YAJ. XB minus XA equal delta X. I plus delta YJ. This is delta R. So this is the displacement vector. How can we calculate the displacement magnitude, delta R or delta R magnitude? Equal delta X square plus delta Y square. This is the magnitude. The direction, as you see here, we have delta R is directed like this. Delta R A B. The direction, what we can do here, we can put x-axis and y-axis on the tail of the vector. Here we have the tail. We put x and y. You do this all the time to find the direction geometrically. So here we have the angle of delta R AB. The angle of delta R AB equal tangent minus 1, the y component